All right, so this is pretty easy. You just take 74 plus 8 out of how much? Out of 60. This one's a little harder. 14 out of, it's 60 times 60, so it would be 3,600. And that's because that's how many, so imagine it this way. Everybody look at the clock right now. How many minutes are in an hour? How many seconds are in an hour? 3,600, because it's 60 minutes, but each minute has 60, right? So it's 60 times 60 to get how many seconds are in an hour. So now just put this in your calculator. You can do it all at once. 74 plus 8 divided by 60 plus 14 divided by 3,600. You can do it all at once in your calculator. Nope. And the reason why is because your calculator is stupid and it obsessively follows rules. So sorry, Sophia.
It's okay. This is having one class, right?
Hey, Friday. This is happening again.
Okay.
Anybody else? Is there another one I'm missing? Is it just Friday? Okay. And to be fair, Sophia, I would say I forgot to tell you, but somebody told me this morning, and I was like, what? Like, I should have known, because I'm like the teacher, but didn't, so. Calculators they will automatically do PEMDAS. So this one is 8 divided by 60 and 14 divided by 360, or 3,600. And it'll do those two first before adding it, so you don't need parentheses around this one. If you added them, it certainly wouldn't hurt, but it wouldn't make it a problem. All right, so 74.137 about. Not bad. All right, let's try again. Yes.
So is the decreasing, is that like if you're telling time, or what is the decrease? Is that not telling time?
A degrees, it's an angle.
Oh.
Yeah, remember how we were doing angles up here?
Yeah.
And this is called, the section's called angles?
So they just renamed time to be angles?
So,
So why do we use minutes when we're talking about decrease?
well, there's
That's
lots
what I'm
of,
talking about.
there's lots
Why do we use a decimal?
Okay, because it's easier to break it in, I don't know, whoever created this decided they were gonna break it into parts of 60.
So if you use a protractor, you'd be like, okay, minutes on it and stuff.
Yeah.
too?
Like literally, when you get to small enough, they have protractors that are so small that it will measure in minutes and seconds.
What? I don't understand, but like, why would you be like, ooh, this is like.
All right, we're gonna Google,
Wow, this is
Why?
15 minutes right here. I don't get it.
why, you know that's not, right? Do you
No
know,
what?
okay, so do you know that, how big is 1 degree? Like if you had to like make that angle with your fingers, how big would it be?
1 degree?
Mm-hmm.
Well, it'd be like, if this is 90.
Yeah, that's 90 of them, right there. So where's 1 degree? Super teeny, okay?
So it's a
And
second?
then in that super teeny sliver, there's 60 dividers, right? 60 pieces. And then each one of those slivers has 60 pieces in that.
So like
Yeah, so they're like super tiny. So when you're like, oh look, my calculator is 6 minute, no, this is not a flat line, is definitely not. All right, why do they use
Why don't
minutes?
they just call them like little bits? Or, like,
Okay, you're not the one arguing with Justin.
Yeah, it's bigger.
All right,
Or why don't they just say like, this is like
Justin, go for it.
0.0000000 like 2 degrees.
And that's like how you can see all the.
all right, this is a question. It says, come on. I hate that.
Wait, so I
Stupid
was gonna ask them
school
how many
system's
minutes
always
are in
like,
circle.
you can't learn that. Why does the geographic coordinate system, and by the way, this is also how they measure, so when you're thinking about tiny things, imagine now that the big circle, the 360, is really big. So imagine it is the Earth.
Okay.
Like latitude and longitude is measured in degrees and minutes and seconds. And that is important because even when it's really tiny, the difference between seconds is miles. Do you understand? So, for example, let's look up the latitude, longitude of Lewiston, Minnesota. Has anybody ever looked this up before? Okay.
We're starting off, I thought we were adding time, but we aren't doing that.
So, here is the exact coordinates of Lewiston, Minnesota. It is, we are 43 degrees, 59 minutes, 2.39 seconds north, and our longitude is negative 91 degrees, 52 minutes, and 5.99 seconds
From where?
from the equator and
Going
the whatever that time zone line is. What is that called?
Standard time?
Mm. Prime meridian. Get a prize.
Huh.
Wow.
How fast are they going? If it's talking in minutes.
No, no.
It's
No, it's not about time. Okay, it's just, I think we're just gonna move on, maybe. We'll just move on. All right, so let's say it was 34.817 decimals 2 degrees. All right, this one's a little harder to understand. So it's definitely 34 degrees, right? That's easy. And then you're gonna take, in your calculator, take 0.817, because that's like 81%, right? Almost 82%, times 60. So put that in your calculator. And that's gonna tell you how many minutes there are.
You always times it by 60?
Yes, because that's how many minutes are in a degree. And you should have gotten 49, right? And some change, 0.02. Okay, and this time what you're gonna do is you're gonna say, okay, that's 35 degrees, and it's 49 minutes, and then you're gonna take 0.02 and multiply that by 60 as well to find out the seconds. So you're gonna take the remainder of the leftover stuff and multiply it by 60, and that gives you what, 1.2? So we'll round it to 34 degrees, 49 minutes, and 1 second. So this is important in stuff like construction, contracting, especially when you're trying to figure out the grade of a road and how things go with that, making sure things are safe and that they actually line up when you build things, but also really important when it comes to finding out your exact location. If you're like, well, who cares about exact location? That is how GPS works, and you use it almost all the time. So don't be like, no, I've never used GPS. Yes, you have, or you haven't gone places that are interesting. Okay? If you only go from your house to your school and your school to the house, that's... Maybe find some new places to go, okay? Maybe you'll find a place that you need to use a GPS for. All right, just a couple more left. Example 7. Good thing we're recording this, so you can watch it later.
Yeah, just relax.
All right, example 7. By the way, we're going to example 8, so we're almost done. This one's gonna be pretty easy. All right, maybe we'll go to example 9, but it's very simple. All right, we're going to talk about a little bit about a unit circle here. And the question that Kyle was asking, which was it Kyle or no, Thomas, right? You said, what if it's over 360? All right, so part of your homework is going to be asking, not a perfect circle, but I would suggest maybe draw the circle first and then the X in the middle if you want to make it look better than mine. It's supposed to be a circle right there. You know, like there's some math teachers who can make perfect circles? Nope. Yep. Do you remember what the quadrants are called? Do you remember where the first quadrant is? It's this one right here. And where's the second quadrant?
The bottom one.
No, it's the one to the left, 3, 4, 5, it goes counterclockwise. All right, so traditionally, this is 0 degrees here. 90 degrees is up here. See how I'm just gonna keep going around the circle? What's this over here? 180 down here? 270. And where is 360?
0.
All right, 360 is back at 0, right? So I'm going to write 360 here now. If I keep going, 360 plus 90 is